Alright, in this video we're going to review factoring. The type of factoring we have here is a trinomial whose leading coefficient is 1. Alright, the way we do this is you have to figure out what is it that multiplies to 10 but adds to negative 7. Alright, so we do this by creating a factor sum table. Alright, so what we have to do is we have to figure out the factors, so the things that multiply to a positive 10 but add to a negative 7. Alright, well we know that a negative times a negative equals a positive, and a negative plus a negative equals a negative, so my two factors are going to have to be negative. Alright, so that means I could have negative 2 times negative 5. I could also have negative 1 times negative 10. Alright, but negative 2 plus negative 5 is negative 7. Negative 1 plus negative 10 is negative 11. So these are the two factors that I want. So when I take this trinomial and factor it out, it's going to factor into x minus 2 times x minus 5. Alright, same thing for number 2. I want to know what is it that multiplies to a negative 32 but adds to a negative 4. Alright, so this time when I do my factor sum table, I want to multiply to a negative, but add to a negative. The only way I can do that is if my two factors, one has to be negative and one has to be positive, because a negative times a positive is a negative, and then a negative plus a positive is going to give me a negative. So when I do this, my bigger factor is going to have to be negative. So my factors of 32 would be 2 times negative 16. Alright, but when you add those two things together, you get negative 14, so that's not going to work. My next factor would be 4, and I have 4 times negative 8, because 4 times negative 8 is negative 32. But then 4 plus negative 8 is negative 4, and that's what we were looking for. So that means that my two binomials would be x plus 4 times x minus 8. Alright, now we have a leading coefficient, a trinomial whose leading coefficient is not 1. Alright, so now we're going to do the same thing we did before, but we have to do one step in the beginning and one step at the end. So what we have to do first is take this 5 and multiply it to the end to rewrite our trinomial as x squared plus 24x minus 25, because now since there's no leading coefficient, I can do my factor sum table. Alright, so what I want to know is what is it that's going to multiply to a negative 25 but add to a positive 24. So I know my two factors have to be negative, because a negative times a positive is a negative, and a negative plus a positive could give me a positive. So now my bigger factor is going to have to be positive. Alright, so we've got 5 times negative 5. Alright, but 5 plus negative 5 is 0. Then I also have negative 1 times 25, and negative 1 plus 25 gives me 24. So those are my two factors. So we've got x minus 1 times x plus 25. Alright, but in the very beginning we took this 5 and multiplied it, so now we have to take it back out by dividing it. Alright, so we're going to reduce these if we can. 1 over 5 doesn't reduce, so it's still x minus 1 over 5. Alright, but here, 25 over 5 reduces to 5. The last thing you have to look for is if there's still something in the denominator, it's going to slide right in front of that binomial, so you're going to have 5x minus 1 times x plus 5, and that would be your final answer. Alright, now another type of factoring that we have is the difference of perfect squares. Alright, when you have the difference of perfect squares, you have to check for three things. Number 1, there is a difference, and number 2, the two terms that you have are perfect squares. Alright, I'm not sure how you learned this before, but the way that I've kind of taught this is you have these two things here. So you've got a thing 1 and you've got a thing 2. In the very end, when you're done, you're going to take thing 1 and you're going to add it to thing 2, and you're also going to do thing 1 minus thing 2. Alright, so as long as there's a difference, this type of factoring is going to work. And when you do this, thing 1 is x squared, thing 2 is 81. So now, when you do the difference of perfect squares factoring, you take the square roots of both of those things. So thing 1 would be x, and thing 2 would be 9. So then you do thing 1 plus thing 2 times thing 1 minus thing 2. So you would have x plus 9 times x minus 9. Alright, now this type of factoring is the GCF. So what you want to do is you want to figure out what these two things have in common. When you look at 3a cubed and 33a, they both have 3a. Alright, so now when you take out a GCF, you're dividing both of those terms by what they have in common. So when you have a 3a cubed and you divide it by 3a, you're left with an a squared. Bring down your minus, and then 33 divided by 3 is 11, and a divided by a is just 1. So you're left with 3a times a squared minus 11. Alright, the last type of factoring we're going to review is by grouping. Alright, so when you do by grouping, it's because you had 4 terms. Alright, so what you want to do is you want to group your first 2 terms together, and you want to group your last 2 terms together. When you get to this part right here, once you've grouped everything, you're going to find a GCF in each one. Alright, so the GCF of c cubed and minus 8c squared is c squared. The GCF here is going to be 6. So that means in this first one, we're going to take out a c squared, and when you take out a c squared, you're left with c minus 8. Alright, now plus, bring down the GCF from the second one, and then you're going to take out this 6, and when you factor that out, 6 divided by 6 leaves you with c, and then 48 divided by 6 leaves you with minus 8. Alright, then when you get to this part right here, you're going to notice that this and this are exactly the same. So this is now going to factor into c minus 8, and then in the other binomial is going to be the 2 things that were left over, which is c squared plus 6. Alright, now I want you to take these 4, and I want you to try these 4 by yourself.